In privatization, we talked about a way to remove the conflicts between various processes over a particular variable. We can also use reduction to do that, although the conflicts are not completely removed. Reduction just decreases the number of conflicts. Let's say we want to perform some operation on all elements of a large matrix. And if we did that sequentially, we have to iterate over the whole matrix. We don't want to do that, so we assign different processors the task of iterating over certain portions of the matrix, and they can do that in parallel. Then they get done and they've got a partial contribution to the overall sum or product or whatever it is. And then after they're all done, we can add those together to form the total sum or product. In order to do this, we could, as we suggested, use addition or multiplication. It's also possible to do reduction with logical operators such as and or. What do they have to be in order to allow reduction? The criteria are that the reduction variable needs to be updated by each task, and it doesn't matter what order the updates occur in. That's because when you separate the work into a variety of tasks, you don't know which task is going to get ahead of the other task, and the result needs to be the same regardless of who's ahead and who's behind. And that means that the reduction operation needs to have a couple of characteristics that operators can have. And I wonder if you can think of what they are as we pause for a second. Yes, the reduction operator needs to be commutative and associative. So to see that in a little bit more detail, we can talk about exactly what's going on here. We want to compute y as the result of applying an operator to all elements of x given a certain initial value of y. The op is a reduction operator. If it's commutative, which means that you do u op v is the same as v op u, and associative, if you're going to do u op v op w, you could either do the u op v first or the v op w first. So those are the criteria for reduction. And again, reduction doesn't get rid of all the conflicts because it's still necessary at the end for a single process to add up the global sums. But it does reduce the conflict. And so when we talk about reduction, we're usually talking about taking some data structure that's k dimensions and turning it into a k minus 1 dimensional structure. In the case that we saw above, it was a two-dimensional array to turn it into a single scalar by applying the same operation between adjacent elements of the array.